Hi, I'm Gwanghyun at SNU. Author of DATID-3D, diversity preserved domain adaptation using text-to-image diffusion for 3D generative model. Let's start with quick overview. DATID-3D enables to fine-tune 3D generative model, leveraging text-to-image diffusion to synthesize high-resolution, multiple-constant images, preserving diversity and 3D geometry in text-guided domains without massive images and camera parameters. DATID-3D consists of three main steps: text-guided post-aware target dataset generation, clip and post reconstruction-based filtering, and diversity-preserved domain adaptation. DATID-3D demonstrates superior quality, diversity, and text-image correspondence to the baselines. Our pipeline is able to be extended for instance-selected domain adaptation, and single-view manipulated 3D reconstruction as well. Let's see our work in more detail. Recently, there has been a growing interest in creating 3D contents to build high quality of virtual reality and metaverse. To achieve this, 3D generative models that take a camera parameters as well as random latent input for post-control synthesis are proposed. SOTA 3D generative models achieve remarkable performance in synthesizing high-resolution photorealistic images with view consistency and detailed 3D shapes. However, training these SOTA 3D generative models is challenging. In addition to requiring a large number of training images, as in the case of 2D generative models, they also require information of post-distribution. As a result, 3D generative models can only be trained on a small number of domains. One possible solution is to utilize the text-guided domain adaptation for 2D generative models, which enable to perform text-driven domain adaptation without collecting images from target domains, by leveraging clip encoders trained on large-scale image text pair datasets. However, naive extension of 2D text-guided domain adaptation methods to 3D generative models show catastrophic loss of diversity inherent in a text prompt due to the deterministic embedding of the clip text encoder. For example, Pixar has various styles, such as Toy Story and The Incredibles. However, as you can see in the results, they all tend to have the same style, as if they were a part of one family. Also, these approaches show inferior text-image correspondence and poor image quality. To address these issues, we propose DATID-3D, diversity-preserved domain adaptation using text-to-image diffusion for 3D generative model. Our novel pipeline enables the synthesis of high-quality multi-view constant images with strong text-image correspondence in the text-guided domains, while maintaining diversity and the 3D geometry. To achieve diversity-preserved domain adaptation, we leverage stochastic text-to-image diffusion for the text guidance rather than deterministic clip embedding. DATID-3D is divided into three main stages: text-guided post-aware dataset generation, clip-based and post-reconstruction-based filtering, and diversity-preserved domain adaptation. When training the model naively with images generated through the text-image diffusion from the random latent, the model loses its post-controllability and 3D shape. To resolve this, we propose text-guided post-aware target dataset generation. First, we generate images in specific poses using the 3D generator. Then, we create images in the target domain with preserved poses through text-guided image-to-image manipulation. By repeating this n times, we construct a raw data set consisting of sets of camera parameter, source image, and target image. Due to the high stochastic nature of the text-to-image diffusion model, raw target dataset includes some target images that show low text-to-image correspondence or raw post consistency. To filter out such cases and improve text-image correspondence and post consistency of target images, we perform clip-based filtering and post-reconstruction-based filtering using a pre-trained post extractor. Once we obtain the refined dataset, it's time to fine-tune the 3D generator. While we could perform non-adversarial training using clip image directional training with these images, we found that this approach would result in the loss of text diversity and suboptimal quality. Therefore, we utilized the adversarial loss ADA loss and additionally leveraged density regularization to help preserve the 3D shape. We compared the results of the DATID-3D with existing 2D text-guided domain adaptation methods extended for the 3D generative models, and DATID-3D demonstrates superior quality, diversity, and text-image correspondence to the baselines. Also, the results of user study using the mean opinion score for text correspondence, photorealism, and diversity demonstrated the best performance of our method across all categories. To fully enjoy the diversity of the text, we proposed the instance selected domain adaptation that selects one of diverse styles in each text prompt and adapts the generator on it. First, we fine-tune the text image diffusion on a single selected image, and then we replace the text image diffusion in stage 1 with the fine-tuned text image diffusion, and operate the DATID-3D again. As a result, we are able to generate images like the ones on the right, corresponding to various styles of pixel. Finally, we propose single-view manipulated 3D reconstruction combining the 3D GAN inversion and the DATID-3D method. Previously, there were methods for 2D manipulation and 3D reconstruction using a single image. Our method enables to lift text-guided manipulated images to 3D and to choose one among diverse styles from one text prompt. In conclusion, we propose DATID-3D, a method of diversity-preserved domain adaptation tailored for 3D generative models leveraging text-to-image diffusion models. We also provide interactive demos. Play with our demo and code if you're interested. Thank you for your attention.